6.1 is a pretty, I would say just not a very difficult section. We're talking about how to graph radical expressions and functions. And when we graph radical expressions and functions, we only deal with the positive answer. I know that you guys, when we talked about this, we said if you take the square root of 4, you can have two answers, plus or minus 2, because the square root of 4 is equal to 2 times 2, and it is equal to negative 2 times negative 2. That's how we got our 2 and our negative 2. But when we're graphing it, we are not going to mess with the negative answer. We're only going to put down the positive answer. We're not going to go backwards and try to get that negative answer. It won't show up on your graph that way. So on this very first problem, when we're graphing the square root of x, they went ahead and told us some things to plug in for x. They told us to plug 0 in and see what we get, to plug in 1, plug in 2, plug in 3, and to plug in 4. So I already know that they want me to plug those in. They told me to. So when I work this problem, all I'm doing is, instead of x, I'm putting in what they want me to plug in. So I'm saying, well, what's the square root of 0? And remember, we're only working with the positive answer here. The square root of 1. If we were working an actual problem, we would actually put plus or minus, but we're just working the graph part of this. I left the square root of 2, because it doesn't come out pretty. It's like a decimal answer. It's not nice. So I'm going to see if we can just graph it with the points that we got. The square root of 4 is 2. So all we're doing is plugging in our x's, and that will give us our answer for our y. So we've got a point at 0, 0, 1, 1. The next one I can really see without having to figure out what the decimal is 4, 2. So I plotted 0, 0, 1, 1, and 4, 2. And that really is enough for me to kind of tell what shape my graph is making. Kind of makes like half of a U, but turns sideways. And it does keep getting wider and wider. In other words, it keeps getting taller and taller and taller. I've got it leveled off probably a little bit too much. Let me back up. I have it leveled off just a little bit too much, I think. So the graph kind of does this, but it does keep kind of going up. It just slows down a little bit. Okay. Is everybody okay with that? So the domain of the function, when we talk about what can x be, the domain of this function, well, we don't have anything. If you start from the left and go to the right, the first time we come to an x is right here, when x is equal to 0, but it keeps on going forever. So that's why they're saying the domain, it can be equal to 0 to infinity. Another way to write that is all x's such that x is greater than or equal to 0. Okay. So all this problem is saying to do is break this down. This is our function, and they're saying, well, tell me what f of 2 is. And they also want you to tell, well, what is f of negative 4? So all this is saying is when x is 2, what is y? So you would have to go to your function. So we want to say, well, x is 2. Wherever we see an x, we're going to put a 2 in. And we're just finding the answer. So this would be 4 times 2 minus 3, which is 5. So square root of 5. I don't need. Okay, and whenever I plug in a negative 4, this is not talking about the graph though, so this could be our plus or minus, right? When I plug in a negative 4, f of negative 4 is equal to 4 times negative 4 minus 3. Well, 4 times negative 4 is negative 16, and negative 16 minus 3 is a negative 19. Okay, and do you guys kind of remember what we talked about when we were solving quadratics? That the square root of negative 1 is equal to I. Y'all remember that a little bit? So this one actually would be plus or minus because negative 19 can be written as -1 times 19. So this is really plus or minus I because the square root of -1 is I times the square root of 19. 19 is prime. There's nothing I can pull out of it or factor out of it. So that would be the end of that. We can't really mess with that anymore. All that's asking you to do is plug something in for X and find the answer. Bless you. Okay. So this says the domain of F is the set of all X values for which the radicand is non-negative. Radicand is just a fancy word for saying square root. Okay, and so far we've had problems in the domain where we have a fraction, right? So we've said if we wrote down 3 over X plus 3, you would tell me, well, X plus 3 cannot be equal to 0. We'd have a problem in the domain there. Okay, we've talked about this just a little bit, but now we've got a problem in the domain where there's a square root and you cannot take the square root of a negative number. If you do that, it's going to be an imaginary number and our graph does not hold imaginary numbers. So what we're concerned about is whatever is underneath the square root can't be negative. And if it can't be negative, it has to be greater than or equal to 0. Okay, so this only exists wherever whatever's underneath the square root is greater than or equal to 0. So we could add 15 here. We are solving an absolute value, an inequality problem. So if we have to multiply or divide by a negative number, what do we have to do to the sign? Flip it, but we're just adding 15 here, so we don't have to mess with it. So our domain can start at 15 and go to infinity, but it has to be greater than or equal to 15 because anything less than 15 is going to make this be negative. So if I plugged in a 14 minus 15 is -1, and that's going to give me an imaginary number. Okay, so you have to have all of this stuff bigger than or equal to 0. So this one, 2x plus 5, whatever's underneath the square root, has to be greater than or equal to 0. So we're going to subtract 5 from both sides of the inequality. I'm not dividing by a negative number, so I'm good there. I am going to divide by 2. Still not dividing by a negative number though. So anything greater than or equal to -5 over 2. Type in your calculator or in your brain -5 divided by 2, it's -2.5. So -2.5 to infinity is okay. But if I were to put -4 in here or anything less than -2.5, it's not going to work. It's going to make me have a negative number and I can't take the square root of a negative number. Another way to write these two would be all x's such that x is greater than or equal to 15. All x's such that x is greater than or equal to -2.5. Okay, we've worked with both of those notations a lot. So we need to graph x minus 3. They've told me already what my values are for x. They picked them for me. Okay, so all I am doing is wherever I see an x, because I'm using this, I'm plugging in what they want me to plug in for x. And I'm trying to find the answer by doing that. Okay. So the first time they tell me to plug in a 3, then a 4, and a 7, a 0, and a 1. So I'm just coming along here and plugging in the stuff I need to plug in. Okay, so 3 minus 3 is 0, and the square root of 0 is 0. So that's just 3, 0. 4 minus 3 is 1, and the square root of 1 is just 1. On the graph, we know it could be a positive or negative 1, but since we're graphing this, just going to look at the positive side. The square root of 7, or 7 minus 3 is the square root of 4, which is 2. That would kind of be off my graph. So here's 6. This would be 7, 2. Okay, so here's that ugly 0 minus 3 is negative 3. You can't take the square root of a negative number. And so it would be I square root of 3. It's not even going to fit on our graph. 1 minus 3 is negative square root of negative 2, which would be I square root of 2. Okay, and you guys should already kind of recognize, well, if we've been doing the translation of functions, that this minus 3, all it did was take our little square root and it shifted it to the right 3. Because it's opposite of whatever's inside. When we were moving those things around, all we did was take this to the right 3. But what I don't want to happen is, let me go to the graphing calculator real quick. That's rough out there. So I'm going to do square root of x minus 3. And graph it just to make sure that we got it right. If I want to look at my table, do you see all of those errors? Why are those errors there? Because when we plug -7 in for x, or -4, or -1, or any of these numbers that have errors, it's going to give us a square root of a negative number underneath, and they don't exist on this graph. So they're imaginary. So the first time that we see something is 3, 0, 4 is 1. Okay, so that's why you're getting these errors on your graph when you see those. Okay, so what's going to happen to this graph? Got a +2 added to my original function of the square root. What happens to that thing? What's the +2 do to it? Yeah, it's going to shift it up 2, right? All it does is shift it up 2. So when I'm going to plug in, I'm going to plug in these numbers and see what I get. So I'll have some points. You could absolutely get this from your graphing calculator, but when I do this, I will get 2 plus the square root of -1. Well, that's going to give me an imaginary number, right? That would be 2 plus I. I can't graph that point. If I plug in a 0 for x, I would get, that's going to give me just 2. So I'd have a point at 0, 2. If I plug in 1, I would have, that's going to be 2 plus 1, which is 3. I'd have a point at 1, 3. If I plug in 2, that is 2, and then 2 plus the square root of 2. We plug in 4, that would end up being 4 because we've got 2 plus 2, so 4. So I'm going to graph some of these. I know I'm going to graph this one and this one and this one. They look kind of easy. 0, 2, 1, 3, and 4, 2. Kind of look like that. Still look like that half of a U. If I go to my graphing calculator, this one would be here, would be a decimal value, whatever 2 plus the square root of 2 is, that would be there. But this one right here would say error when I looked at -1. It wouldn't be there because you can't take the square root of a negative number and it show up on these graphs. Doesn't have negative numbers on a 2-dimensional graph. Doesn't have the square, let me rephrase that. Doesn't have the square root of negative numbers on a 2-dimensional graph because they're imaginary. 4. Oh, this needs to be 4, 4. Thank you. Yeah, because this is 2 plus the square root of 4, which is 2. And I put it right here. I guess I just didn't. 4, 4. Thank you for fixing that for me. Is everybody okay with this? It's basically just plugging in what they tell us to plug in, finding the answer, plotting the points, and talking about the domain. So f of x equals the square root of 1 minus 2x. They're telling me already what they want me to use for my x value. They're saying use 1, 1/2, 0, -1, -2. So what I'm doing is replacing that x with whatever they're telling me to let x be. Okay, so they tell me to let it be 1, like 1/2, 0, -1, -2. And you're going to see that sometimes these negative numbers end up being something that's positive after we get done with this. So this one is 1 minus 2, and 1 minus 2 is -1. So we would take the square root of a -1. That's just I. So on your calculator, when you look up 1, if you type y equals in your calculator and you looked at the table, 1 would give you an error because you can't take the square root of a negative number. This one's 2 times 1/2, and 1/2 of 2 is 1. So this one ends up being the square root of 0. Well, that's fine. We can do that. 1/2, 0. Be right in the middle of these two. 1 minus 0, that's the square root of 1. So that's going to give us 1. So 0, 1. We plug in -1, a negative times a negative is positive. So this is going to end up being 1 plus 2, which is the square root of 3. And then this one's going to be 1 plus, because we've got a negative times a negative, that's going to be positive 4, square root of 5. And I'm going to look up one of these on my calculator just so that we can get some kind of an estimate, because we really need one other point to plot. Square root of 5 is approximately 2 point. So I'm going to change this. Approximately 2.236. So I'm going to plot the point -2 and go just a little bit above 2. So this one kind of goes the opposite direction. What's the domain of this function? Remember, domain is talking about x's. So if always start with -infinity and move in. So it looks like this arrow is going to keep going to -infinity. So our domain would be from -infinity. Okay, and I heard somebody say to 1/2, and that is absolutely right, because that's the last place. And can it be equal to 1/2? It can be equal to 1/2, right? So that means that it doesn't get a parentheses, it gets a bracket. It can be equal to 1/2. Okay. That one, that's kind of, I feel like that's not a real difficult one. Questions about anything on 6.1 before we look at 6.8?